Hey everyone! Today we're diving into something massive, the fight against cancer. But we're looking at it through a totally new lens, an AI lens, that is giving doctors what you could almost call a superpower, the ability to see the invisible. Let's jump right in.
So let me ask you this. How would you find one tiny critical detail in a really blurry, noisy photograph? It's tough, right? Well, that's pretty much the challenge oncologists face every single day with some of our most advanced medical scans. And that exact problem is why AI is about to change absolutely everything.
Okay, so to really wrap our heads around this, we first have to talk about a field called nuclear oncology. I know it sounds super complex, but the idea behind it is actually brilliant. Doctors use these special radioactive tracers that act like tiny little beacons. Once they're in your body, they're designed to light up cancerous cells on scans like PET or SPECT. It gives us this incredible window into what's happening. But that window isn't always perfectly clear.
And this is where we hit a snag. For all their incredible power, these scans can be low resolution, they can be full of what we call visual noise, and ultimately, their interpretation can be subjective. Think about it. Two different world-class experts could look at the exact same fuzzy image and see two slightly different things. And when a diagnosis can change a life, that's a really big deal.
So here's the difference in a nutshell. On one side, you have traditional imaging. It can be low-res, noisy, and it really relies on human interpretation. But on the other side, you've got AI-powered imaging. We're talking high-quality, automated detection, and precise analysis. The leap forward is like going from an old, staticky analog TV signal to crystal-clear 4K. You just see so much more. So how on earth does AI actually do this? Well, that brings us to its first huge impact, taking the very images doctors work with and making them dramatically better. You could almost think of it like the world's smartest autofocus. AI's number one job, right out of the gate, is to take that noisy, low-resolution scan and digitally sharpen it, bringing details into focus that might have been completely missed before. So how does it actually work? Well, it's kind of like a three-step dance. First, the original noisy scan gets fed into the system. Then these powerful deep learning algorithms just get to work, sifting through all the data and basically cleaning up the image. And what comes out on the other side? A high-quality, clear image where even tiny, early-stage tumors can suddenly pop into view. This isn't just a small upgrade. For early detection, it's a total game-changer. But getting a clear image? That's just the beginning. What comes next is honestly even more incredible. The AI performs something called segmentation. Imagine a digital scalpel with a perfectly steady hand, precisely tracing the exact outline of the tumor. This isn't just about being accurate, it's about being safe. It means treatments like radiation can be aimed with laser-like precision, protecting healthy tissue while hitting the cancer with everything you've got.
Okay, so AI gives us this stunningly sharp image. Now what? What do we do with all that new information? This is where the next revolution begins, using that clarity to build a truly personalized treatment plan for every single patient.
You see, a clearer picture is great, but AI goes deeper. It starts doing what's called quantitative imaging, analyzing things like how quickly the tumor is soaking up that radioactive tracer. This data tells doctors not just where the cancer is, but how aggressive it is. It's like a behavioral profile that helps them choose the absolute best treatment, whether that's chemo, immunotherapy, or something else. And this leads us to one of the most exciting ideas in all of medicine right now. Diagnostics. It's a mashup of therapy and diagnostics, and the concept is just revolutionary. You use a single radioactive drug that first travels to the cancer so you can see it on a scan, and then that very same drug delivers a targeted dose of radiation to treat it. See it, treat it, all in one. But how do you make that see it, treat it approach perfectly safe? How do you get the dose just right? That's where AI-driven dosimetry comes in. It's like having a supercomputer act as the ultimate safety co-pilot. It calculates the absolute perfect radiation dose, one that's powerful enough to destroy the tumor, but precise enough to spare the healthy cells all around it. Right, but a tumor doesn't exist in a vacuum. To treat it effectively, you need to see the whole context, the entire story. This is where AI's ability to combine different kinds of information becomes another one of its superpowers. Okay, think of it like we're building a complete profile of the cancer. First up, you've got your PET scan. This tells us about the tumor's function. How active is it? Is it growing fast? Is it aggressive? Then we layer on the CT scan. This gives us the anatomy. It's the structural map showing us exactly where the tumor is, its size, and how it's sitting next to other vital organs.
And finally, we bring in the MRI. This gives us that incredible soft tissue detail. It's like a high-definition close-up, revealing things like the tumor's blood supply. Each one of these is a crucial piece of the puzzle. Now, on their own, these scans are incredibly powerful, but AI is the magic that fuses them all together. It takes the what it's doing from the PET, the where it is from the CT, and the what it looks like up close from the MRI, and it combines them into one single comprehensive map. For the first time, doctors can truly see the cancer from every single angle, all at once.
All of this is incredibly promising, right? But what does the road ahead really look like? Let's talk about the challenges we still need to clear and the amazing future this technology is helping us build.
Now, of course, this isn't some simple plug-and-play solution. There are some real hurdles here. AI is hungry for data. Tons of high-quality, standardized data. We also have to be able to peek inside the AI's black box and understand why it's making a certain recommendation. And then there's the huge challenge of getting regulatory approval and integrating this technology seamlessly into busy hospitals around the world. But if we can clear those hurdles, wow. The destination is just incredible. We are talking about a future where early detection is the norm, not the exception. Where treatments are tailored not just to the type of cancer, but to the individual person. And maybe, most importantly, a future where this level of advanced care isn't just for a select few, but is accessible to everyone, everywhere. And that leaves us with one last really powerful thought. For decades, medicine has been mostly reactive. We find cancer after it appears, and then we fight it. But with AI's ability to see patterns in data that are invisible to the human eye, we are moving toward a future where we might be able to predict and intercept cancer before it ever gets a chance to take hold. A future that isn't just about treating disease, but about preventing it in the first place.